Hi everyone! Welcome back to another video on the wonderful subject of calculus. And at the end of the Calculus 1 course, you typically learn about area and volume, and that's what this video happens to be about, all about volume. Now make sure to check out my channel because I have some other videos about area and volume, which like I said, typically comes at the end of a Calculus 1 course. And if you haven't subscribed already, make sure to subscribe below because I post weekly videos that'll help you with your learning of calculus. So let's take a look. In this problem, it says to find the volume of the solid obtained by rotating the region bounded by x equals negative 6 plus y squared and x equals negative y about the line x equals negative 9. And all of these functions have been graphed below, and you can see that in this diagram. Now, one thing I do notice is that both of these functions are written in terms of y, which kind of tells me something that when we get to it, I'll show you. But let's first think about what we're doing here. We're taking this region that's bounded, and you can see that that's the region between the linear function and this sideways parabola. So that region in there, we're taking that region and we're rotating it about this vertical line right here at x equals negative 9. Now imagine taking that shape and now you are rotating it around that axis of revolution. And so visualize that, because I'm really bad at drawing it, but just visualize that. And let's say I were to cut it right through the middle and show you a cross section. That cross section is going to be really an outer circle and an inner circle, which a lot of times you hear being called a washer. Now I have another video where you find the volume of revolution using a washer. So click here to see that video in which the washer is vertical. Now this one, the washer will be horizontal. So keep that in mind. And because this washer is horizontal, you're going to be stacking up an infinite amount of washers from bottom to top. Now, because you are stacking washers and we want to add an infinite amount of washers in order to get the volume of this region, of this solid, we are going to use in calculus an integral. And that's why calculus is so amazing to allow us to find the volume of this solid. Now, because we are stacking washers this way, well, let me go back to that. Not only do I know that because the functions are written in terms of y, which you can't always follow that rule, we either need to think if the washers will be going up and down, which we really can't because we can't do like the top function minus the bottom function here because they're the same exact function. And also you're rotating around a vertical axis. So that tells you that each washer, when you go to revolve it, each washer is going to have, that width. Now, if I took that and cut it out and put it over here, you'd have this inner circle and you'd have this outer circle. And I want to find the area of that region because that's the region that's being revolved around. Now, to do that, what I'm going to have to do is, I think the best way to find the area of this washer is to first calculate the area of this outer circle right here. And I'm going to call the radius a capital R. So that area would be pi, I said capital R and then used a lowercase r. Let's try that again. Capital R squared, because the area of a circle is pi r squared, with r being the radius. Then I want to subtract out this inner circle right here in white, which I'm going to say the radius is lowercase r, so I'm going to subtract off pi lowercase r squared. That difference is going to give me that pink shaded region of what we call a washer. Now to put it into this integral, I am adding up an infinite amount of washers from this y value here. Now, this y value appears to be negative 3. I'm just going to make sure that that is at negative 3 where these functions intersect. So if I plug in a y value of negative 3 into this first one, I would get that x is negative 6 plus negative 3 squared, or negative 6 plus 9, which is 3. That matches up with the x value there. Now let me make sure if I plug in a -3 here, that x would be the opposite of -3, which is +3. Okay, yes, so sure enough, just to confirm, that intersection point is 3, -3. So I'm adding up an infinite amount of washers from -3 to an upper y value, which is right here, and that looks to be at the point -2, 2. Let me again just plug in quickly that y value of 2. That'd be -6 plus 2 squared, which is 4. Okay, -6 plus 4 is -2. That works. And then to the second function, yes, the x value is in fact the opposite sign of the y value. So just double checking in both functions, we're good to go. So I'm adding up an infinite amount of washers from a y value of -3 to a y value of 2. Now notice we are using the y values, not the x values, like this video did, where I did another washer problem, but I had to use x values since the washers were running vertically. Okay, now I'm going to add up an infinite amount of these washers. And again, the formula was pi r squared minus pi lowercase r squared. Both of them have a pi, and I'm going to factor that pi out. The integral symbol means I'm adding up an infinite amount of these washers, and all of these washers have an area of pi capital R squared minus pi lowercase r squared. So let's find what capital R and lowercase r are. So if I rotate this region around this vertical line, capital R, or the outside radius, is going to be from the axis of revolution to the outside function. That's going to be capital R. So if I put the pi here, capital R is going to be the difference of those two functions, or the linear function, which is -y, minus where the axis of revolution is, which is -9. So I'm subtracting a -9, which is going to change to a plus. Then I am going to subtract out the inside circle. And so the lowercase r is going to be right here, which again, that's going to be the difference of those two functions. And you want to make sure everything is written in terms of y, since your washers are being stacked this way, so the washers are horizontal. So just make sure of that. It's the difference between the two functions, so it's going to be the sideways parabola, and then minus the axis, which is -9. So again, minus a -9 is going to be plus. And there we have it. So that is just what I need to put after my integral right here. Oh, and I forgot to mention, remember I did factor that pi out. So I would just put what I have left with the pi factor out. Don't forget your dy. Always need to make sure to include that when we have an integral. And because the cross sections are running horizontally here or perpendicular to the y-axis, it would be a dy problem. Okay, from here, we're ready to type this into our calculator. And let me move myself out of the way. And notice I have used x's. I didn't use y's. Don't tell anybody, but it's just way easier to press this button right here on the calculator that's next to the alpha symbol that says an x. Again, way easier to do that than try to find where y is on the calculator every time. And notice over here, even though it was a dy problem, yes, I used dx, but it'll work out to be the same thing. And there we have it. 916.298 is going to be our final answer. And moving myself right back up to the top, here I go. And that is how you find the volume of a solid, by taking a region and rotating it about a vertical axis of revolution. I hope you found that video helpful. If you did, make sure to give it a like. Comment below about any questions you have or comments you have about this video. And if you haven't subscribed already, I post weekly videos on calculus to help you with your learning of calculus. So make sure to click subscribe below if you haven't already. Have a great day, everyone, and we'll see you in the next video.